So we'll be talking through some of those models, sort of how they work, what the outputs are, and the sort of results we've seen and our clients have seen with them. And then hopefully, if time permits, I wanted to go into something that the rest of that you all could take away, and that's sort of introducing and talking through the Kedro Python library, which is what we've actually used to build all of our models, and which is an open source Python framework, which is pretty cool for model development, especially in sort of a collaborative team-based environment. All right, so getting started. So sort of how did Prospect come to be? It started with the two founders, namely Gordon Hamilton Fairley and James Tozer. So Gordon was actually interning at the RFU. He interned there for a few years and managed to come across or meet James Tozer, who was a data scientist and data journalist at The Economist at the time, and realized that sort of what he was trying to do would be much better facilitated if he had someone like James working on it. And they actually started back with Stuart Lancaster around 2015, and then got involved with Eddie Jones when he became coach. And there the deal was sort of Eddie really took a liking to the outputs of the models that they were building. And the deal was sort of like, right, tell no one, we want to use this as England going into the World Cup. Plan was for England to win the World Cup, and then they could start a company on the back of that. One of those two things happened, which I'm not too bitter about. And sort of back end of 2019, that's when Prospect was first sort of founded. The guys were still sort of working at The Economist, etc., but sort of back end of 2020 was when they decided to make a real go of it and managed to get sort of funding needed. While they were working with England and Eddie Jones, Steve Borthwick was an assistant coach. And in late 2019, he was offered and took up the position of Leicester Tigers head coach, and asked James and Gordon if they would go along and do all the analytics work for Tigers, which they have since done. And in due course, Prospect has entered into a joint venture with another company called Ellipse, who, if you watch cricket, they're the holders or owners of CricViz. And so we went into a joint partnership with them where they are responsible for the collection of the raw rugby data, and we provide the analytics services on top. So as Prospect, all our rugby related products are now done through an entity called Oval Insights. I might use them interchangeably in this talk. A bit about the team. So Gordon and James were our two founders. And sort of this time last year, it was the four of us, sort of Gordon, James, myself, and Elliot Glass. But we've grown to sort of 12 or 13 full-time members now, and have a number of advisors and consultants, generally from sort of the sporting disciplines and backgrounds. For example, Rob Andrew, ex-England rugby player. Cool. So in terms of services that we offer at Prospect, can largely be bucketed into four categories. So data and analytics, and this is primarily concerned with the performance side of sports, and that's what we'll be talking about today. So in terms of rugby, we're still working with the RFU, so England Rugby, Leicester Tigers, and closer to home in South Africa with the Sharks. We also have a media advisory, mergers and acquisition, and then also sort of your more general or generic strategic consulting. And what we look to do is we actually look to have sort of take a very, very rigorous and data-driven approach to all four of these different business arms, and sort of it's been really cool to see sort of how the performance side and that sort of data analysis feeds into these other three. But yeah, for today, I'll be focusing more on the performance analytics side. So this is sort of an excerpt from Eddie Jones's book, just talking about sort of the earlier work that had been done with them for England, but won't spend too much time on that. So now we'll go into sort of how the model works. And it's actually interesting. I think like in most sort of analytical modeling across different industries, the models are informed by sort of subject matter experts, and there's a lot of back and forth. So I think a lot of our models and products have been born out of trying to answer questions and problems that our clients had. And one of them earlier on was that Eddie Jones came to us and said, look, I'm getting pages and pages of stats after each rugby match. And I've got an idea about which stats are important in sort of determining which team actually wins the game. But he wasn't 100% sure. And that's something he tasked us with. So quite a fun exercise that we do is we've got 2 games here, 2 international matches. And we sort of stripped away the context in terms of who the teams playing were and who won. And so I'd invite you, so sort of if we look at game 1 first, who wants to say sort of whether it was team A or team B that won and why? And then we could, depending on time, we could look to do it for game 2. So if anybody wants to unmute their microphone and have a crack at saying, and it's actually quite funny, we've done this with coaches and players who are involved in these games and they haven't got it right.
Hey.
So for game 1, you say team A won. Any particular reason?
Well, I look at penalties conceded, those kind of things, tackles made. Yeah, I'm not an expert, but I just look at the numbers quickly.
Yeah, no, of course. Anybody want to counter that? Anybody want to say team B for game 1?
I'm leaning towards what Hans said. Looking at the stats, it looks as though A is more likely. But whether that's what happens is a different question.
Okay, cool. Maybe game 2. Anybody want to say team A or team B?
Team B, I think.
Team B, any particular reason? Yeah, anyway, it's not important. I think the message here is that it's not inherently clear looking at, especially just purely count-based statistics, who should have won a rugby game. So yeah, Hans, you were right. Game 1, it was team A. That was actually the game, I think, back end of 2018 when Ireland beat New Zealand. And team B, game 2 was shortly afterwards when England then went on to beat Ireland. So given that problem that Eddie had, what the guy, when I say we, I wasn't quite involved in this just yet. But what the guys did was able to develop a predictive model, which was able to pull out certain features. They sort of threw all this match data that they had at the model, and it was able to pull out which features were really predictive from that. And then based on that, could build a model in determining sort of what your actual win rate or win percentage should have been. And this is a tool which a lot of the coaches we work with really, really enjoy, because I think sort of looking at it from the public view outside in, the end scoreline is sort of the be all and end all. But for coaches, they want to see that they are in fact making progress. So what you can see here, hopefully it's not too faint, is England's win rates, both their expected and actual, for a 10-game rolling average. So this is when the guys sort of first approached Eddie Jones when he had just taken on the coaching role, and he went on an unbelievable sort of 18-game unbeaten streak. So you could see his actual win rate was outperforming the expected. And the guys sort of said, look, you're doing well, but you shouldn't have been doing that well. And he wasn't too interested in hearing from them then. Then 2018 rolled around, went on tour to Australia, got beaten, went on tour to South Africa, got beaten as well pretty badly. And it was at this point, Eddie said, okay, can you help me tell me why we're losing? And it's something that we see often, is that teams will often revert to this mean. sort of they can fight gravity for a while, but more often than not, they revert to it. And this is when he started taking on board sort of the outputs of the models, where teams were vulnerable, why they perhaps hadn't got over the line in a game. And what this does is it helps sort of bring a context to the game. So oftentimes you find teams lose a match that essentially they should have won, and vice versa. And it sort of helps strip away that essentially the bounce of a rugby ball in some cases from the actual outputs. And so we can plot this for a number of different teams, and what you see here is that it helps keeps things in context, because around sort of 2015 here, Wallabies made the World Cup final. They did so on the back of a pretty dodgy call in the quarterfinal against Scotland by Craig Hubert, a game they definitely shouldn't have won. But in the media, the whole narrative was Australia is a force to be reckoned with in World Rugby again. After that, again, we saw they pretty soon reverted to the mean. And yeah, they expected win rate never really got above 60, 70. And this is just similar plots for other teams. Here, this plotted quite nicely sort of the Springboks improvement back end of 2017 through to the World Cup. One particular case which was a big selling point with the coaches was with the Irish. So this was before, again, sort of leading into the 2019 World Cup. It's become a bit of a pattern where Ireland seem to find themselves as the best team in the world a year out from the World Cup, and then absolutely bomb at it. But this was when they had just beaten the All Blacks for the first time. They had won the Six Nations. But our model was saying, look, they're good, but they're not that good. A lot of times they got a few wins where they definitely should have lost. But the whole narrative was that Ireland, best team in the world, Ireland are going to win the World Cup. This was sort of in the lead up to when they were going to play England in the following Six Nations. And in the press, it was not a single Englishman would make the Irish team. Ireland are going to absolutely hammer England. And we were able to say they're not as good as everybody thinks, and here's why. Here's where they're vulnerable. And England then went on to beat them. That was actually that game 2 example. And here you can see where after that their results tailed off. They reverted back to their expected win rate. So that's essentially what we call our game model. And then we also have what is our player model. And how the player model works is it introduces a concept of expected points in rugby, which is not something new. It's been around in football for a while. It's known as sort of expected goals there. And it's a lot of what it is based on what's been implemented already in US sports, who are sort of far and away the world leaders in sort of application of analytics and extracting value from analytics in sports. And so we based a lot of what we've done on what's been done there. So if you can think about expected points as it's almost like a game of snakes and ladders. So the closer you get to your opposition try line, in terms of your field position, the higher your sort of probability of scoring next, and so the higher your expected points. So for example, you can see here, if you've got a ruck or scrum or something on halfway, and then you're able to progress from halfway to your opposition 10-meter line, so your expected points at that point in time for that given play increases from 0.4 to 0.8. And then what we do is essentially, so here's an example. England have a ruck just inside their own half. It's then sort of past scrum half to fly off puts up a contestable, and it's claimed by the wing inside the Irish half. So that's going from an expected points position of 0.1 to an expected points position of 0.9. So what we've done is we've essentially trained models to learn that for a given part of the field, for a given type of play, what is your expected points? And then we make a whole lot of adjustments in that to adjust for sort of things like your opposition, the actual team you're playing in, what position you're playing. So everything's sort of adjusted to the mean for a number of different categories. And then what we've essentially done, turning that into a commercial product, for example, in the URC this season, is that they have a fantasy product and they're actually basing the fantasy points on the outputs of our player model, slightly more aggregated and dumbed down, or not dumbed down, but a bit more simple, for two reasons. One is sort of protection of our IP that goes into that model. And secondly is just making it a bit more understandable, a bit more consumable for your everyday rugby fan. So this gives a breakdown of sort of what those XP values are for a number of different sort of actions that happen in a rugby game. For our actual sort of player model that we use for sort of in-game analysis and player recruitment, it's a bit more intricate, but I wouldn't say it's sort of worlds apart from what we have here. So I think one very, very cool aspect of this is that where you have these sort of points allocation systems in different sports, even in rugby, those are largely very, very subjective, where this is inherently very objective. So it's based on sort of the scoring actions of thousands and thousands of rugby games that these models have been trained on. So essentially how it works, sorry, I'm just trying to move my Zoom window around so I can read this out, is, for example, when a player makes a successful jackal or a turnover at the ruck, he's increased his side's chance of scoring by a certain percentage, and that translates essentially into 0.6 points. Similarly, you can see the effect, sort of the negative effects if a player gets a yellow card or a red card, what that actually has on the game. And I guess sort of where the more intricate parts come with the actual sort of, I'd say professional version that we're using is it's more cognizant of field position, time in the match, etc. Cool. And so another aspect which people say, and this player model is very, very sort of on the ball focused. So that's based on the data we're collecting, which is very, very on the ball focused. But like we know, rugby, like a lot of sports, there's a lot more that goes on and can make a player valuable than what's actually happening on the ball. And again, we're learning from US sports. Often when you say I'm working in analytics and sport, people say, oh, like Moneyball. And the approach of Moneyball was actually to say, forget whatever any coach or scout is going to say. All you need to know is in the data. And we've adopted more of an Astro Ball approach, which was adopted by the Houston Astros. And that's looking to sort of supplement the analytics and data with inputs of subject matter experts like coaches, scouts, ex-players, etc. And that's what we've got. We've got teams of these ex-players, coaches, scouts, who focus on the different leagues which we're capturing data for. And they can give a lot of sort of more intangible inputs on what a player does really well on a rugby field and what it maybe doesn't do so well. And we've seen that's improved the sort of performance of our models hugely. Cool. So now to get into some of the results. So you can imagine for a given game, you've got sort of these expected points associated with the actions of different players. You can aggregate those over a game, and then you can aggregate those games over a season and those seasons over a career. And what you essentially find is that you're now able to rank players relative to their peers in their position, teams, etc. And what we get out of this is a player model. And you know sort of which actions the player has sort of earned or lost expected points for. And so you can you can essentially rank them not just overall, but according to the different sort of metrics that are prevalent in a rugby match. So this is just an example. We've got a fly half playing in country Z. Pretty good. Overall ranking is 9.7, so that would be out of 10. So your best player in that position in the world is going to be a 10. Your worst is going to be a 0. And so this has been sort of the teams we've worked with. They absolutely love this when it comes to recruiting, because I think rugby is behind a lot of sports and a lot of facets, but recruiting definitely, it's very, very reactive and not very proactive. And what this does is it provides sort of a point of departure when it comes to player recruiting, that they may have a scout have brought a player to their attention, or they've seen someone on video, and they can then drill down and say, okay, what do his numbers actually look like? Because I think human bias is you're more inclined to remember sort of the really flashy moment of brilliance that a player does, so much so that it offsets a lot of negative things that they tend to do. And that sort of stuff doesn't escape the attention of the models. So we've got our more objective rankings up top here, and then in the bottom corner, that's where we're able to supplement it with the more intangible sort of subjective inputs of the coaches and scouts where we actually have them. And then also what we were able to do is we were provided with salary data for a few players in a few different leagues, and we were able to put that into sort of bands. And we were then able to scatter that against sort of the value that a player is seen to be adding, how much he helps a team win, and how much we're actually paying them. And this again sort of points to the inefficiency of the recruitment market in rugby. So you can see here, you've got in your left top quadrant, pretty expensive players who are not doing a lot. And this could be maybe they are international players, so you're paying them a hell of a lot of money, but they're not necessarily turning out for your club that often. And vice versa, you could have some really young players who are absolutely shooting the lights out, and you're not paying them very much for now. That would say, okay, maybe we want to bump their salary up a bit, so that you're getting your squad sort of falling in this band here. And then sort of, as well as tying this in together, which is what we've done for Leicester, sort of both the pre-match, in-match, and post-match performance analytics, as well as helping them with their recruitment. Leicester have had an unbelievable turnaround in form, and we are in no way, shape, or form trying to take all the credit for that. They have an incredible coaching staff, but it's something we've been involved with. So when Steve Borthwick took over, Leicester were the worst club in the English Premier League. They would have been relegated had Saracens not been relegated for financial infringements. So this was back end of 2019. In the 2021 season, Leicester were sort of the most improved team from the season before. Sorry, in terms of points, points in the actual sort of season table. And as of now, they are top of the English Premier League. They've won 14 of their 16 games and 11 points clear. We were hoping for an unbeaten season at one stage, but obviously at the time of writing or generating this, we knew that they would be reverting to their expected win rate. But they're still having an unbelievable season as it's going. And then sort of what's been born out of the on-field performance analytics is sort of products we've been able to build and commercialize and been able to sell to things like broadcasters and leagues. So if you've been watching any of the URC this season, all the on-field stats is provided by us, and we've got models here like your kick predictor, so your kick success. So based on where a kick's being taken from, what the angle is, what your sort of average kicker's probability would be. And we're working to incorporate sort of kicker effects into that. So we can say for this particular kicker, this is what the probability would be of him kicking this goal. Oh yeah, and I should say sort of, so we've got all these models, the player models, the game model. How do we know that they're actually any good? And I think the ultimate sort of bullshit test is, do they help you predict who's going to win a rugby game? And that has very much been the case for us. So we're providing our pre-match forecast to the URC, which they've sort of wrapped as the URC Stats Master, and are sort of using those in a Super Brew competition. And of 36,000 people, I think we were 58th last time I checked. So a bit of room for improvement, but we comprehensively beat the betting markets. We don't bet. We're not allowed to because of our involvement with professional teams. But yeah, we comprehensively beating the betting markets and other sort of publicly available score prediction sites, that at least the ones we're aware of. We're also able to generate sort of in-game win probabilities. So based on the current status of a match, as well as a number of other sort of in-game metrics that we're collecting, we're able to say at this given point of time, what is team A's probability of winning, team B's probability, and what is the probability of a draw. Also, which we've built, which hasn't been rolled out just yet onto TV, is sort of a score probability model. So let's say a team is awarded a penalty, we can say what the probability of them scoring a try would be if they take sort of a line out, if they take a scrum, a quick tap, etc. And we can either do sort of what the probability of scoring is, or what the expected points of those different decisions would be. Yeah, so that's it. That's it on the rugby side. I just want to see. Okay, I've got a bit of time. So now I'd actually like to chat a bit about Kedro, and which is a platform we've used to actually build all of these models in. So it's born out of the idea of addressing a number of challenges in applying machine learning, or sort of building data science and analytics products in general in organizations. A number of, I think anybody who's worked with data will know that data is initially always crap. You often have sort of unclear objectives. People are like, well, let's do the AI and let's do the data science. But a lot of times it's sort of something never really makes it past your pilot stage or proof of concept. And that's because it's easy to get it there, but getting it incorporated, implemented into production is a whole different kettle of fish, and can be very, very challenging. And yeah, I guess sort of it's oftentimes it's this research versus production mindset. So that's also sort of why something like Kedro exists. And often when you're working in teams of developers, it can increase workflow variance. Everybody's got their different sort of strengths and weaknesses and how they go about writing code. And I think what Kedro does is it sort of looks to provide a unified and uniform solution and approach to doing this. It also looks to implement what is called clean code and sort of coding best practices as far as possible, which makes that transition from sort of proof of concept to production that much easier. So I think core to this is it looks to bring sort of software development best practices to writing code. And then, yeah, just looking to, like I said, bridging that gap between development and production, which this is something I learned from sort of working with McKinsey, is that often sort of internal company teams that have built all these really cool pilots projects, but they never really make it through to production. And this is something, I guess, when I joined Prospect, we had a whole lot of R scripts and Jupyter notebooks and everything floating about. And we wanted to sort of try and build an actual production ready model from this. And that's where we sort of took all of that and then shoehorned it into sort of what is known as these Kedro pipelines. And it's really made sort of the model development, deployment, running a hell of a lot more efficient and easier for all of us. So what is it exactly? It's an open source Python library. It's developed and maintained by QuantumBlack. So that was sort of like the analytics division of McKinsey. This isn't a promo or anything for them, I promise. But as of a couple of weeks ago, it had just been donated to the, I forget the name now, it'll come to me. But yeah, so, and like I said, it looks to bridge the gap between machine learning and software engineering. If you're familiar with working in Python, it's pretty much as easy as pip install Kedro. You can check them out online. They've got a lot of very, very cool tutorials, which makes learning the sort of foundational building blocks very, very easy. What it is it's essentially 5 core elements. The one is a uniform project template. So whenever you sort of create a new Kedro project, it's based on the sort of cookie cutter approach. It sets up your project template. So you know where your data is, you know where your source code is, you know where your outputs are, and that makes it really, really easy when you're part of an organization which has a number of different projects on the go, and you're moving from one to another. Having that sort of consistency and uniformity makes it a lot easier to sort of orientate yourself in a project. It's also got what it's considered its configuration. So as far as possible, it makes it easy for you to keep things like hard-coded file paths, hard-coded parameters out of your code, so that as you're working, when you're done, you can sort of package it up and deploy it. If you're working across different people working on the project, you never have that, or as far as possible, you don't have that problem. Well, it works on my machine. I don't know why it's not working on your machine. It's got a concept of a data catalog, which is very, very cool. So all you need to do is just specify sort of in this data catalog where the data is, what type of file it is. Is it a sort of PySpark data frame? Is it a pickle object? Is it a CSV? And in doing that, Kedro handles all the sort of reading and writing of that for you. You don't explicitly ever have to do like pd.read CSV or anything like that. It handles all of that for you. And then I'd say the core functionality is this concept of nodes and pipelines, where a node is essentially, it looks to introduce that the approach that the SRP, the single responsibility principle of a code function, and making your code as modular as possible. So each node can be seen essentially as one sort of Python function, and it has an input, a function, and an output. And then you have a pipeline, which is just a collection of nodes, or a DAG, as they call it, a directed anti-cyclic graph, so that the outputs of one node could potentially be sort of used as inputs to another. And I'd say, yeah, that's pretty much an overview of what Kedro is, or at least the main building blocks. And if you've worked in Python before, there won't be a lot new in terms of syntax or anything like that. Other cool plugins is it has this sort of Kedro Viz aspect, which it allows you to essentially visualize your pipeline, which is really, really cool for sort of code review, sprint meetings, being able to say sort of where you are in a project. It allows you to sort of trace where data is used throughout your pipeline. And yeah, especially when you're learning about if you moved on to a project, sort of orientating yourself, understanding sort of how the code is actually working. This is very, very cool. And again, it's sort of like one command and you get your entire model visualized. And then there are a number of different plugins for it. So there's Docker plugins. So when you're done with your modeling, you can sort of package it up and deploy it as needed. We've integrated, there's an ML flow plugin, so we use that for sort of our model monitoring and also sort of experimentation when we're looking to optimize our models, which has been pretty cool. Yeah, and I think that's about it. So I managed to squeeze it into 40 minutes. Would be happy to chat about anything or answer any questions that anybody has on any of the above.